All right, stats, welcome to a quick video over the first day or two in Chapter 2. Chapter 2 is all about mean, standard deviation, outliers, box plot, and such. Good stuff here. So here's an example. Do write this down, folks. Now that we're, a week and a half in this thing, any video I make is your notes. And if you don't have your notes, that's just, that's not acceptable, okay? So a video I put up is your notes. You have to have notes down. All right, give the 5-number summary and create a box plot for the following distribution. So box plots are what we have done on Group A and B here. Also state any outliers using the 1.5 times inner quartile range rule. So here are your numbers: 87, 79, 86, 90, 94, 91, 83, 88, 84, 88, 79, 61, 85, 93, 90, 94, 89, 87. Maybe there are scores on 18 exams you have throughout an entire academic year. You're very consistent students. Maybe you're like, it's the same professor all year, and you're like, this test is unfair, and you're consistent, and maybe you have something to back it up. You prepare the whole way, and you're like, hey man, you should really throw this one out. You can see, look at my data. This shouldn't happen, this 61, if everything else is equal. So is 61 an outlier, yes or no? So first off, you got to order them. You got to put them in order. There are 18 total. 18 total means there's a first 9 and a second 9, so it's not an odd number. So there are 2 that tie for that true middle. When you put them in order, 61 to 94, you can see I skipped 1, 90, 91. That is what that is. Put them in order. I want to see you put them in an order there. Again, I need to see a lot of work on this, or else you just won't be getting as much credit. Few of you, I definitely be a good idea to show me, what work you have, so that you don't lose points for not showing enough work. Okay, putting them in order, and then noticing, okay, 87 and 88 would be the ones that would tie in the middle. 8 before, 8 after, those 2 in the middle. Okay. Okay, when you have an even number, there will be 2 that tie for that, quote, true middle. So the median is the middle of 87 and 88, which is 87.5, the median there. All right, so the min is obviously 61. The max is a 94. So the first half is the first 9. The second half is the second 9. So in the first 9, 84 would be the true middle. Cancel, 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 cancel. 84 is quartile 1. It is the middle of the first half. Same thing here. Cancel, 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 cancel. 90 is the middle of the second half. Quartile 3. Okay, so quartile 1 and quartile 3, that's only a difference of 6, because you're very consistent. Look how many scores you have that are within 10 points of each other. You have 14 scores that are exam scores that are between 10 points of each other. Probably not a huge standard deviation, even with that 61 in there. So here's the box plot. In the box plot, draw a line down, min, max, straight line across. 61 to 94 is a difference of 33. The median is about 80% of the way over, so there's the median. 90 is basically the max. Quartile 3, that's quartile 1 at 84. So your middle 50%, is way over here. It's way far away of 61. So my question is 61 an outlier? Again, we can show mathematically. Here, I'm going to give you 2 different ways. First is using the 1.5 times IQR rule. Again, inner quartile range, everyone write this down. This is the formula that I give you. Inner quartile range is quartile 3 minus quartile 1. 90 minus 84 is 6. So you have 1.5 times 6 is 9. That's that value we need. We need 1.5 times the inner quartile range. The inner quartile range just tells you like how much separates your middle 50% of data. 1.5 times IQR is 9. If I'm trying to catch a high outlier, I need to add something to quartile 3. If I'm trying to catch a low outlier, I need to subtract something from quartile 1. So I take quartile 1 and I subtract that 9, which is the 1.5 times IQR. I take quartile 3, which is 90, and I add 9. So now I have the interval from 75 to 99. What that means is any number between 75 and 99 is not an outlier. So even 75 and even 99, if that was in my data sets, it would not be an outlier. Any number outside of it, so 100 here would be an outlier, and 74 and less would be an outlier. That means 61 is definitely an outlier. 61 is way far away from that. We've done a few that have only been like an outlier by 2 or 3 or something. 61 is way off. Now, here's what I want to show you on the next page is how using your calculator we can get the mean and the standard deviations. So let's get both calculators out. First off, this is the TI-84, which some of you will use, the TI-84 Plus here. It has, as you know, a stat button. Hit stat. When you hit stat, sometimes you'll need to clear a list. So you go to clear list, and then you'll type in list 1, and you'll hit enter, and it'll say done. I don't want to clear that because I already typed this in. So stat, edit, I typed all those numbers in. What you do is you just hit 87, enter, goes down, 79, enter, and so forth, all the way down to my, you did this in honors algebra 2, 18th number. Then I'm done. So when I'm done, I'm going to hit second stat. Second stat, I'm going to quit out of it. I'm sorry, hit second mode, hit quit, literally hit quit. All right, second mode. Now I want to figure out the mean and the standard deviation. So I hit stats, I go over to calculate one variable statistics. You only put an X in there. You only put one thing in there. It's one variable. All right. So you did put your data in list 1. Don't worry about a frequency list. You don't want any of that. So you're going to go down and hit calculate. X bar is 86. The sample, we're going to treat everything as a sample. The sample standard deviation is 7.63. As we'll learn Wednesday and Thursday, we're going to treat everything as a sample. This is the population standard deviation. And we know why the sample is a little bit bigger. You'll know why Wednesday or Thursday. We're going to do the sample standard deviation, 7.63, always rounded 2 decimal places. All right. Then, so we know that. We know the mean is 86, and the sample standard deviation is 7.63. I'm going to show you how to do that using the TI-30XS. Hit on. Then, folks, it's right here, data. Data. Instead of having 6 lists, this has 3, no big deal. So again, I type in 87, enter, 79, enter. Here I don't think it has a clear list, so if you wanted to delete something, you know, you could start from the bottom of the list or the top of it and just hit delete, 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 delete until the list is gone. Okay, like here, if I had 8, 8, 7, 9, I would just hit delete, 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 boom, gone. Okay, anyway, I have typed in all those numbers, hit enter. Again, you will have 18 of them. Then hit second mode, quit out of it. For you guys using this calculator, you can hit second stat, 1 variable statistics, the data is in list 1, frequency 1, just leave it at 1, and then go all the way down to calc. And you're given the mean, sample mean, X bar, 86, sample standard deviation of 7.63. Again, that's what we want. So no matter what calculator you use, that's what you got. Now, folks, when we're not making box plots or caring about the IQR, not making a 5-number summary, there's another way to catch outliers, another rule, and we're going to use this more often this year because we're only doing box plots and interquartile variances chapter, but the mean and the standard deviation will be here with us literally the entire year. The mean plus or minus twice the standard deviation. You may also see it in some books, population mean plus or minus twice the population standard deviation. We can always also do the sample mean plus or minus twice the sample standard deviation. The sample mean is 86, plus or minus twice the sample standard deviation. And then you make an interval, 70.74. You take 86 and you subtract 15.26. You take 86 and you add 15.26. So any number in that interval is not an outlier. So in this one, 100 would not be an outlier. In the last one, 100 would have been. Again, I've compared the two. So there's a little bit of difference. So here, this will allow for a few more outliers. The one using 1.5 IQR will allow for a few more outliers, but this one will not. Okay, so this one utilizes standard deviation. This one we're going to use more often. This is, again, this is a way we can use it. Again, when we first learned that, we didn't know anything about finding standard deviation. You might not even know the word. So we're going to carry this forward. You might have to do this a few times in Chapter 2, though, on a quiz or exam and on your homework. But this way, we really love the mean plus or minus twice the standard deviation. It doesn't matter. 61 is such an outlier that even here, it is still an outlier. Something like if I would have had a 73, outlier, not an outlier here, outlier there. So there obviously there's a little bit of a difference between the two. Both can be used going forward. This is the way we're going to do it. All right, you need to have down these notes. You need to have down these notes, folks, especially by Friday when we talk again. This is Yak Math Videos signing out.